A team of researchers working at NASA's Goddard Space Flight Center has developed a model designed to show what the early moon may have looked like. As you take into account in your paper loaded on the preprint server, studying the rocks of the area between the near and far side of the moon could reinforce your theory, and if you determine probabilities to be correct, could have impact theories regarding how the moon formed. A class consensus among space scientists holds that an object, about the size of Mars, struck modern and Earth's billion years ago, touching some surface material in space-time as the material joined to become our moon. But what happened between the time of the moon was formed and now remains rather a mystery. A collision between massive objects would create a lot of heat, which means that if such a collision resulted in the formation of the moon, both would have been extremely hot for a long period of time thereafter. In this new effort, researchers have used the results of previous efforts, such as examining lunar rocks, to construct a model that they believe could possibly represent the actual story of the moon not long after it was formed, based on a Mart-type collision. The researchers report that their model shows the moon covered by a thick ocean of melted rock. In such a scenario, possibly volatile sodium atoms would have vaporized, over time, the formation of an atmosphere. But because only one side of the moon faced the Earth, the atmosphere would have been very different on its near and far sides. The model showed much of the atmosphere closer to Earth vaporization due to the heat of the nearby planet. It also showed large temperature differences between the near and far sides of the moon, a situation that would have resulted in very strong winds enough to cause waves on the hot ocean surface.